In this video, I will continue looking at chain rule, and specifically the chain rule related to trigonometric functions. And we'll start back at number 51. So here we have a product of sine 2x and cosine 2x. So h prime of x will be the first times the derivative of the second. So sine of 2x times the derivative of cosine of 2x. Derivative of cosine is negative sine. We'll leave the inside alone, then multiply by the derivative of the inside function. So that's times 2. So that's the first times the derivative of the second, plus the second, cosine 2x, times the derivative of the first, which is also cosine. Leave the inside alone, so that's 2x, times the derivative of 2x, which will be 2. So simplifying this gives negative 2 sine square of 2x plus 2 times cosine square of 2x. Now we can rewrite this and factor out the 2, and we would get 2 times cosine square of 2x minus sine square of 2x. And that happens to be a trigonometric identity. Cosine of 2 alpha is cosine square of alpha minus sine square of alpha. So in this case, we would have cosine of 4 alpha, or 4x as our variable is here. So cosine square of 2x minus sine square of 2x is cosine of 4x, and 2 times that would be 2 cosine of 4x. We'll go into number 52. 52, we have another product. We have g of theta is secant of 1/2 theta plus tangent of 1/2 theta. And we'll have to do a product rule again. So we'll say g prime of theta is the first times the derivative of the second. So we get secant of 1/2 theta times the derivative of tan 1/2 theta, and the derivative of tangent is secant squared. We'll leave the inside alone, then times the derivative of the inside will be 1/2. So that's the first times the derivative of the second, plus the second times the derivative of the first will be the derivative of secant is secant tan. So we'll leave the inside alone as 1/2 theta. Then multiply that whole thing by the derivative of 1/2 theta, which is 1/2. And so we get some crazy things here. We have secant actually to the third power, 1/2 secant to the third power of 1/2 theta. That takes care of the whole left term. Then on the right side we'll have 1/2, then tan square of 1/2 theta times secant theta, or secant of 1/2 theta. Now we could go a step further to factor out 1/2 and a secant theta, secant 1/2 theta. And that'll leave secant square of 1/2 theta plus tangent square of 1/2 theta. And we do have an identity that says tan square alpha plus 1 is secant square alpha. But that's not really going to help us there, because secant squared plus tangent squared doesn't really doesn't work with that. So I would leave this as it is. That's going to be fine. And we'll go on to 53. And for number 53, I'll rewrite it and scroll down. We have 53 is f of x is equal to cotangent of x over sine of x. Now there are a couple of ways we could do this. We can use the quotient rule and leave the cotangent as it is, or we can rewrite the cotangent as cosine over sine, and we would get cosine of x over sine square of x. But I think that using cotangent and sine should be fine. So f prime of x using the quotient rule is low. The derivative of cotangent x is negative cosecant square of x. And minus high d low, which is cosine of x, and all over low squared, sine square of x. Now when we simplify, you want to remember that cosecant is 1 over sine, and cotangent is cosine over sine. So when we simplify this, one of the sines in the numerator and denominator will cancel. We'll get negative 1 over sine x minus cosine square of x over sine x, all divided by sine square of x. And simplifying, I get something like negative cosine square x plus 1 quantity over sine cubed of x. And that doesn't match our identity, and so we'll leave it just as it is, and that'll be it for 53.